All right, this is lecture 5.2a. We have learned about forces in section 5.1, and we learned about laws of Newton's laws. And we have now we're going to start applying them. We're going to start using this Newton's laws to actually solve some problems. So, first law, what does it say? That if the sum of the forces is equal to 0, then the object will remain, let's see if I can talk and write at the same time. The object will remain at rest or in motion, right? It won't have any acceleration, basically. Okay, that's the first law. So this is the first law. What does the second law tells me? Well, if the sum of the forces does not equal 0, then I will have acceleration. Okay, and the third law states that for every, it's an action, reaction, right? For every action force, there is an equal and opposite reaction force. So what are we going to do with all that? Well, we're going to solve lots of problems with that. So here's the strategy. I'm not sure where these numbers came from. Here's the strategy. First thing we need to do, we need to read the problem once through, then read it again and underline all the data that's given and implied. Draw a picture of the problem, identifying all the data that's given, direction of velocity and acceleration, and indicate forces with arrows. Draw a free body diagram based on the labeled picture. Okay, we are going to have a lesson just on free body diagrams. If additional objects are involved, draw a separate free body diagram for them. Choose convenient coordinates for each object. Then we are going to apply Newton's second law. We are going to sum the forces in the x direction and sum the forces in the y direction. And we will end up with two equations and two unknowns in a lot of cases. And then solve for your desired quantity and substitute the numbers. Okay, so here's a problem. We have a picture. I have astronaut 1 and astronaut 2. They're both pushing on a satellite. And we have been told that they're pushing both with a force of 46 newtons. And I have a feeling I'm going to need to look up the mass of that satellite. But nevertheless, I want to draw a free body diagram. The dot represents the satellite. Astronaut number 1 is pushing to the right with a force, I'll call that F1, of 46 newtons. Astronaut number 2 is pushing up, call that F2, and he is pushing at a force of 46 newtons. Okay, I've just found the mass of this satellite, which was left off and should not have been left off. And the mass of that satellite is 940 kilograms. So this mass is equal to 940 kilograms. And this is the mass of the satellite. Okay, so we want to know what the satellite's acceleration is. So I'm going to come up here and take a look at this. I see, this is how we're going to solve it. We know that the sum of the forces in the x direction is equal to the mass of the satellite times the acceleration in the x direction. Well, let's go look in the x direction. Here we go. How many forces do I have in the x direction? I only have one. So the sum of all the forces, I got to add up all the forces. So F1 is positive, it's to the right. I don't have to add any other forces because there's no other forces in the x direction. That is equal to the mass of the satellite times the acceleration in the x direction. So if I solve for acceleration in the x direction, I can divide both sides by m, and I get that force 1 divided by m is equal to acceleration in the x direction. That was 46 newtons divided by 900 and what did I say it was? 40 kilograms. that is equal to acceleration in the x direction, and that is 46 divided by 940 gives me 0.0489. I'm not going to round right now, and you'll see why in just a minute. 489, I'll call it 4 meters per second squared. Well, that was the acceleration in the x direction. What do we have going on in the y direction? Well, I have a force in the y direction. I have one force in the y direction. I have the sum of the forces in the y direction is equal to mass times the acceleration in the y. Well, the sum of the forces in the y, that means I have to add all the forces up in the y direction. How many forces do I have in the y direction? I just have one. It's F2, it's upward, so it's positive, is equal to mass times acceleration in the y. I don't know if I said y before, but we're focusing on the y. And so I need to solve for acceleration in the y direction. So I'm going to divide each side by mass. And I will get F2 divided by m equals acceleration in the y. And that will give me the exact same number because they have the same force. So I will find the acceleration in the y direction as equal to exactly the same acceleration in the x. This is meters per second squared equals AY. Okay, they didn't ask for the acceleration in the y direction. They didn't ask for the acceleration in the x direction. They asked it in what is the acceleration of the satellite? Well, these are vectors. And so if this is the acceleration in the x direction, we know that to be 0.0489 meters per second squared, 94, I believe. And this one is 0.04894 meters per second squared. What is the resultant acceleration and at what angle? Okay, well, how do we solve that? We solve that by saying a squared plus b squared equals c squared. This is c, this is side A, doesn't matter which one. Either side, doesn't matter. A, B, whichever ones you want. A and B doesn't matter. C has to be the hypotenuse. So if I plug that into that equation, I get C is equal to the square root of 0.04894 squared plus 0.04894 squared. And I get, all right, I get 0.069 meters per second squared. So that is the acceleration of the satellite. And what is the angle? You actually will get 45 degrees if you take tangent of theta is equal to this number divided by that number. That becomes tangent theta equals 1. And if you take the inverse tangent, you'll find it to be 45 degrees. So this is the acceleration vector and its angle. And you can see it worked out perfectly here. Now, the assignment is to rework that problem yourself. Okay, so the assignment that I have in Google Classroom 15.1 is to rework that problem using F1 equal to 55 newtons and F2 equal to 40 newtons. Sum the forces in the y direction, sum the forces in the x direction, find the acceleration in each x and y, and then solve for the actual acceleration and the direction. Okay, message me if you have any questions.